Alright everybody, welcome back. Today we were going to be talking about congruency of geometric figures. One of the things that we got to clear up is that congruency is different from similarity, where something could be similar, where you have a triangle, a larger triangle could be similar to a smaller triangle, but congruency means that they have to be pretty much exactly the same shape and size, like a carbon copy. It can't be any smaller or larger, it has to be exact. Alright, so we're looking at this first one here, which looks like a stop sign. It's an octagon. It says the sides of the octagons blank congruent. So we're looking to see if they are or are not congruent. Each side of the outer figure is larger than each side of the inner figure. Well, that contradicts what I just said, so that would mean that the octagons are not congruent because they have to be exactly the same. The inner octagon is slightly smaller than the larger one. And then for our second example here, they want us to determine whether the triangles are congruent. So remember, don't always trust the drawings themselves. You have to go by the numbers. So the first one we're looking at AB. So this is AB here. I'm highlighting it here. AB is 4. Alright. They're saying that lines up with this one, which is PQ. Well, that's also 4, so far we're good. They're both 4. Then BC is 4 as well. And they're saying that goes along with PR. That's 4, so far we're pretty good. And then AC, which is right here, is 6. And then this goes with 5. So we can see that we have a match here, and then we have a 6, but if this was also a 6, we would be good. So far, the triangles are not congruent. Alright, although two sides in one triangle are, right, congruent to two sides in the other, the third sides are not. So that means the overall shapes are not congruent to one another. Alright, this one you have to stick with me here, okay? So we're looking for the missing angle. Alright, so for here we can see that the missing angle is right there. Well, if you go directly across, it's 30. Alright, and then here, I want to erase this for a minute. Alright, so here we have 30 as well here, right? Well, directly across from that angle, right, 30 is Alright, let's restart this one. So we can see that this is a 6-sided figure, right? So we have a hexagon here. So 6 minus 2 times 180, so that the sum of these interior angles have to equal 720 degrees. So what you can do is take, with a calculator, is take 720 degrees, right, and start subtracting the given angles inside. So 720 minus 122 minus 114 minus 123 minus 130 minus 121, and what's left over is 110 degrees. Alright, so we see that that's 110 degrees. Okay, and then if we jump down to this one, well, what we're going to do is you can basically look at this one up here, or what we can do is look straight across, alright, and see that the missing angle, well, the one that's missing from up here was 28, so our missing angle from here is 28. Alright, so it's 28 millimeters, and we can see that the corresponding angles are congruent, and also the corresponding sides are congruent. So both of these hexagons are congruent shapes. Okay, and then this one here, they want us to determine whether the triangles are congruent. So we could say AB, which is 6, that's line AB, equals 6. Looks like it would match up with ED. Remember, these are just a mirror image of each other. So line D is 6. So far we're good. And then we could go with AC. Remember, it doesn't matter where you start. That is 8. And then DF is also 8, which is right here. And then our last one, BC, whoops, we did BC here. That is 10. And then EF is also 10. So since there's matches for all these, we can say that these triangles are, in fact, congruent. It's a yes. Alright. Alright, and then our last one here says determine the unknown measures in the set of congruent polygons. Well, if they're congruent, we know that everything's going to match. So let's go through. This one has all the given angles. So 135, well, that's here. Alright, and then we have 60. Well, that's there. 45 is given. That's there. So the one that's missing is 120 degrees. Alright, and then if we go back and look for the missing side, alright, same thing. Well, now the missing side is over here, so 4 feet. Oh, 4 feet's not given, so the missing side for that one is 4 feet. And we're good to go.